principle of superposition. This we studied in defining electric force. In fact, any vectorial nature is actually following the principle of superposition. I explained to you what the principle of superposition actually means in totality. In its absolute sense, it means when multiple phenomena are happening simultaneously, the total cumulative effect is the vector sum of individual effects. If I have 1 point charge Q and I ask you to find the field at distance R, can you do that? Yes. What if I have one more charge Q, and let's say 20 charges kept, and I ask you, what is the field at any point R now? How do I find it? You can see in the diagram, you have charge Q1, charge Q2, charge Q3, right? What's the question? The question is we are interested in finding the net electric field at point P. How do I do that? Find out individual electric fields due to charge Q1, Q2 and Q3 separately. Can you see that? Q1, Q2 and Q3 separately. And what is the net field at point P? It is the vector sum of individual fields. Now, whether I have 2 charges or 2000 charges, can I find out the field due to the entire arrangement? Yes, I can. Vector sum of individual field values. This is called principle of superposition, and electric field, just like electric force, follows the principle of superposition. Got it? Good. All right. So how about now we apply what we just learned using some numericals, some examples. Let's go on. Question number 1. Find the electric field at the midpoint of the line joining the 2 charges separated by 20 centimeters. 2 charges, 2 individual field values, and I'm supposed to find out the field at point P. What's the process? Find individual fields, apply principle of superposition, and vectorially add the 2 values. Here we go. So Q1 at point P and Q2 at point P will have fields in opposite direction as shown in the diagram, right? And look at the magnitudes also. KQ1 by R1 square by putting Q1 as 10 microcoulombs and R1 as 10 centimeters, and Q2 5 microcoulombs and R2 is again 10 centimeters. Although I am adding these 2 vectors, but because they are oppositely directed, their magnitudes are subtracted. So the value is 9 times 10 to the power 9, which is 1 upon 4 pi epsilon naught. In bracket, as you can see, 10 microcoulomb minus 5 microcoulomb, and I've kept the factor of 10 to the power minus 6 to deal with the micro of the coulomb outside the bracket, and in the denominator is centimeter being converted into meter. Remember, SI unit and square. Don't forget, you have an I cap tagging along because positive x-axis sense was chosen as the right hand side, so that your description of field is absolutely complete. On solving and very simple application, we arrive at the answer. The answer is 45 times 10 to the power 5. Please note the units Newton per coulomb or NC minus 1 I cap.